So continuing on with the last video, we now have piece number 5, piece number 6, and piece number 7, evidence to prove the theory of plate tectonics. And all these three pieces of evidence that we are going to do right now in this video proves that seafloor spreading is in fact occurring at ridges in the middle of oceans at divergent plate boundaries. So piece number 5 is ocean drilling, and essentially what the people did was they went back and forth, what they believed was a ridge, and they basically took different samples on the ocean floor of rock and they radioactively dated it. And what they found was that the rocks that were closest to the ridge were young and rocks that were further from the ridge were old, which proved that the newest rocks are being created at the ridge via a process called seafloor spreading. And once those rocks form at the ridge, they move away from the ridge in both directions at a rate of 2 centimeters per year. So ocean drilling certainly do prove seafloor spreading. Essentially what it means is that once you leave a ridge and you go towards one of the continents, you are actually traveling back in geological time. The other thing that Vine and Matthews, so Fred Vine and Robert and Drummond Matthews discovered, is that polarity shifts from time to time. So normal polarity is when the magnetic north is up and the magnetic south is down. And from time to time we've found that the polarity has switched back and forth. So magnetic north becomes magnetic south and magnetic south becomes magnetic north, as you can see in the diagrams right here. So what Vine and Matthews did was they got in a boat, and behind the boat they towed a magnetometer, and they went back and forth over the ridge in the Indian Ocean, and they recorded the magnetism in the rocks below. And what they did was they found a really cool pattern which they call, and a lot of the world accepts as being magnetic stripes. And so as they moved away from the ridge on one side, they had a section of rock that was normal polarity, went further, section of rock that's reverse polarity, went further, section of rock that's normal polarity, went further, section of rock that's reverse polarity. And the coolest thing is that they saw the exact same pattern on the other side of the ridge. Remember, everything that happens on one side of the ridge happens on the other side of the ridge, because we are in fact proving and believing in seafloor spreading. And they called that magnetic reversals. So magnetic reversals totally prove seafloor spreading. And even if you were to look up in this particular diagram from the evidence above for ocean drilling, you can see N stands for normal polarity, R stands for reverse polarity. So you can see the normals and the reverses as you go back in geological time from the youngest rocks to the oldest rocks, which basically records when the polarity switched from normal to reverse. The third piece of evidence is called paleomagnetism, and basically paleo stands for ancient. So what they're actually doing is they're studying the ancient magnetism on the ocean floor. And what they found is when you look at rocks that are basically a long ways away from the ridge, and you look at the orientation of the minerals in that rock, and for example, I'm talking about minerals like pyroxene or hornblende or olivine. Those minerals have iron in it. So when you look at those minerals, they should align with magnetic north. In this particular case right here, they do not align with magnetic north at all. However, if you could push reverse and literally go backwards 2 centimeters per year, these minerals right here that should line up with magnetic north that don't, they would actually be back here at the ridge, and they would line up with magnetic north, which is where they actually formed. That tells us that everything has went this way. The same thing has occurred over here. So the magnetism now in the rocks do not line up with the magnetic field of the earth, but if you were to go back in time, you would find that it actually do line up with magnetic north. So paleomagnetism, magnetic reversals, and ocean drilling, all three of these things prove that seafloor spreading is taking place at ridges on divergent plate boundaries.